So we are a series of 5 schools, and we work together to plan stuff, and we've planned a set of assessment routines to be done across the school. So in year 1 and year 2, we don't assess with any kind of paper test. We might use a whole class mind map to discuss the words that we know and return to that at the end to discuss the words that we know now. In year 3 and 4, we use an independent mind map like that at the beginning of the topic. And you might write down some words on the board that are the key vocabulary, and maybe a scientist and maybe a process, put them on the board and let the children copy them into their books. And then they would then make links between those words if they know something about it already. Or they might underline with colour coding. So green, yeah, I absolutely know what this means, in which case I get mine to write a sentence to explain it. Or yellow, I've heard it, but I can't explain it yet. And red, I don't know what that is. And then you come back to it later at the end of the topic and get them to reevaluate in a different colour. So if they've done it in pencil to start with, then do it in pen second time, and write sentences for the ones that are now green, and anything more that they can add to their mind map. And from that, you can see what they've learnt over the course of that topic. For year 6, we back that up, so do the same thing again, but we back it up with a paper test, because by that age they're able to manage a paper test. But I always read mine to the children, because children still don't have great test technique at the age of 9 and 10, and they might miss questions or not plot this on the graph when it says plot something on the graph. And the ones that we use are the Ogden Trust quizzes. They're basically old SATs questions that have been realigned for the new curriculum, and they do give a pretty good idea of who understands it and who doesn't. But we were looking beyond the knowledge. We wanted to look at across the school, do their skills also progress? So we've done one set of videos that look at recording and what that looks like in foundation stage all the way up to year 6. This set of videos are all about writing conclusions. So what does a conclusion look like in foundation stage? What does it look like at year 1? And how different is that from what it looks like at year 6? We're not expecting anybody to do conclusions every time that they embark on a bit of an investigation, but we are expecting teachers to teach how to write a decent conclusion, and then this is a way of tracking that. If you carry out these different investigations across your school and get your children to write those conclusions, then you can lay them out at a staff meeting and look for that progression across. So if it's not perfect the first time you do it, that's fine. But it's great to sort of look and see, okay, foundation stage are doing it at this level. Are we still doing it at that level at year 3, or have we moved on in the way we write conclusions? So we would recommend that you teach a level of conclusion writing before you expect the children to be able to do it for these investigations. So you might need to spend some of an English lesson maybe, or a science lesson in advance of carrying out these activities, just to teach them what should be in a conclusion at their level. So let's have a look at what that looks like for different children at different levels. So what should a conclusion look like at foundation stage? Well, at foundation stage, we're not looking for them to write anything, obviously. We're asking just that you listen to what they say and see if they are making comments on what they've observed. It's all about noticing what's going on in the world around them. And on a post-it note, it might be, you know, this one fell to the floor, this one got stuck on a table. That's enough. By the time you get to year 1 and year 2, we're looking for them to use the data they've collected, all the experiments they've done, to answer a particular question. So if it's do taller people jump further, then it would be looking for the evidence that backs that up and say, yes, all the tall people could jump further, and it might be something to do with the fact they got longer legs. So we're just looking for that level of conclusion. At year 3, 4, we might be expecting them to write something down at the end of an experiment. So we're looking for them to use some scientific language and to link what they've seen to the science they've learned about that has caused that phenomenon. By year 5 and 6, we're looking for something like year 3, 4, but a bit more. We're looking for them to notice when their experiment didn't go well, or there was an underlying issue with it, and to evaluate their experiment to some extent, to comment on the fact that they repeated it, so they know that their results are more repeatable and therefore their experimental procedure was all right. So if you can get the same result twice, then you know that you're on the right lines. And also to use scientific language in explaining what they've seen, but also to look for issues in the data and say, oh, that one went too far, or I didn't design this experiment very well. So it's not just looking for a pattern in the data, it's about evaluating it as well. We'd also expect year 5 and 6 to be able to use a line graph by year 5 and be able to pick the right kind of graph in year 6, because if you have continuous data, then you're going to need a line graph. So if it's time or distance along the bottom, then you're going to need a line graph. If you are doing something like which paper was best or which plane design works best, then it's going to be a word across the bottom and you're going to need a bar chart, and children need to be able to work out which kind of graph they are going to use by the time they're at year 5, year 6. So the conclusion needs to sort of reflect that understanding.